Okay, so we're going back to counting here, different types of counting. Today we're going to do product law. Uh, but first, let's start with a Venn diagram. So pause the video here, make your Venn diagram, and then I will do one, and we'll see if we get the same thing, and go from there. So pause it, and then we'll go from here, and you can see my solution. Okay, my solution looks like this. I'm going to label this Instagram, Snapchat, and TikTok. Then I'm going to put this in a box. I'm going to put a U here for universal. Okay. So 20 have all three. So 20 is going to go in the middle here because they're shared with all three. There's 24 that are Instagram and Snapchat. So Instagram and Snapchat is here. There's 24. So 24 minus 20 is going to leave me 4. So there's 4 here. Because altogether 20 and 4 equal 24. There are 23 here. They use TikTok and Snapchat, so I'm right here. So 23 minus 20 is 3. So it's going to give me 3 there. Then 25 use Instagram and TikTok, which is shared here. So 25 minus 20 is 5, so it gives me 5 there. Then 33 use TikTok. So within this green circle, I want to have 33 people. So that's 20, 25, 28. So 35 minus 28 equals 7. So that means there's going to be 7 people that just have TikTok. Then 28 use Snapchat. So inside this blue circle, I want to have 28. So 20 plus 4 plus 3 is 27. So 28 minus 27 is going to leave me with 1 right here. And then, do I have a color left? I'll use orange again. Then this circle here, I need to have, how many people had Instagram? 30 people had Instagram. So I want that circle to contain 30 people. 20 plus 5 plus 4 is 29. Minus, 30 minus 29 is going to give me 1. Now what I have to look at is there's 45 people all together. So I need to make sure there's 45 in all these circles. Not that it's 45 in all circles. We got to figure out how many is in all these circles. Then we'll go from there. So 20 plus 7 plus 3 is 10. That's 30. And this here is another 10. So it's 20 plus 10 plus 10. That's 40. So it's 41 people accounted for in all the circles. That's how many are in all 3 circles. So that means there's 41 people accounted for. There's 4 people who are not included. So those are 4 that do not have any social media. So let's ask some questions with this. Let's go with how many have exactly 2 apps. So exactly 2 apps. Let you think about it for a second. So exactly 2 apps are this number, and this number. They have 2 exactly. That's going to be 9, 12 people altogether. Now I could ask, how many have less than 2? How many have less than 2? The people have less than 2. This person has 1. This person has 1. Those people all have 1 plus these people. Less than 2 is also 0, so that's 11, 12, 13 people have less than 2. Perfect. Okay, that's a quick review. So, what we're doing now is product law. And what product law is for is when you have multiple choices where each choice is independent of the other. So one choice does not affect another choice. Easy example is if I'm getting dressed and I'm putting on a shirt, and you can see how bad of a artist I am here, and I'm putting on pants. Now, hypothetically, if you didn't care about color or whatnot, my choice of shirt doesn't change my choice of pants. They're independent. Okay? So that's what we're looking at here. We're going to go through a whole bunch of questions for it. So, first thing I want to do is I'm going to get you to make a tree diagram. And the way we're going to do this, I'm going to walk through it. At any moment I ask a question, you can pause the video right after I ask a question, see if you can figure it out. We're going to do a whole bunch of questions and solutions, and I'll talk it through. So the best thing for you is get a blank piece of paper in front of you and just work through questions with me as we go. So the first thing is I want to build a tree diagram for this situation. The cone shop offers 4 ice creams, okay, on either a sugar or a waffle cone. So if I was going to make a tree diagram here, my first choice would be sugar or waffle cone. Then my next choice is going to be Rolo, turtle, cookies and creams, or strawberry. And then up here, it's also going to be Rolo, turtle, cookies and cream, or strawberry. So hypothetically, if you look, there's 8 different choices. At the very end, I can make 8 different choices. 5, 6, 7, 8 of what kind of ice cream I get. There's 8 separate choices of what ice cream I could get. So there's 8 choices there of what ice cream I could get. So I could go 8 days in a row and get a different ice cream every day. Okay? So I had 2 choices for cone and 4 choices for ice cream. Oops. Ice cream I had 4 choices. In total, I had 8. So if you can see a shortcut right now of how I go from my choices to my answer, we'll go from there. Now, what if my ice cream shop added, so if they added, I could add sprinkles, or I could have no sprinkles. I don't know why you do that, but you could. How many more choices would we have in total? Well, that would mean this would be here and here. Let me make this a little thinner. As in sprinkles, no sprinkles, sprinkles, no sprinkles, sprinkles, no sprinkles. Now, in the future, you won't have to make a tree diagram for everything. That's a nice little thought. So this leaves me with 1, 2, 3, 4, 5, 6, 7, 8. Another set of 8, 16 choices altogether. Because I had 2 cones, I had 4 ice cream, and I had 2 toppings. Gave me 16. So if you can see mathematically how that works, that's perfect. We'll do one more. Let's go back to my shirt. It's a pretty good shirt. And pants, or bottoms, you could say. So let's say I had 5 shirts and maybe 3 bottoms. Right? So if I were to make a tree diagram with this, I would have, that's not going to be enough room. I'm going to make it nice and big. I'm going to do my pants first. So I have 3 choices of pants. Let's call them shorts, pants, and I don't know. What's another type of? Let's say I'm wearing, boys only have shorts and pants. Let's say there's also a capris. Okay, just for 3 different numbers. Okay, then I have 5 different colors of shirts, let's say. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Therefore, at the very end, I would have 1, 2, 3, 4, 5 different outfits there using my shorts. Let's say I had like a white shirt, blue shirt, so on and so forth. 2, 3, 4, 5. I'd have 5 different outfits with my pants. And I have 5 different outfits with my capris. Right? So like if I had a blue shirt, a red shirt, a white shirt, a orange shirt, and a, what's another color? Yellow shirt. So I'd have 15 total outfits. If you haven't seen it yet, all we're doing when they're independent is we're multiplying these items together. Okay? So let's do some practice questions. And as I ask these, pause the video, work it out by yourself, and see if you get the answer right. So ice cream shop has 4 types of cones: waffle, regular, dipped waffle, 5 different flavors of ice cream: chocolate, vanilla, strawberry, mousse tracks, and cookie dough, and 3 different sauces: cookie, caramel, cotton candy. So how many days can I go to the shop and get different cones each day, assuming I have to pick one of each selection? So I have to pick one of the cones, like one of the flavors. I always have to have a topping. So pause it here for a couple seconds and see if you can get the right answer. So in this case, I have cones. I have 4 choices. I have flavors. I have 5 choices, and I have sauces, which is 3 choices. So I'm going to multiply those together. 4 times 5 is 20. 20 times 3 equals 60. So I could go 60 days in a row and never get a double of the same flavor. I'd always have something different. Right? So let's say in my closet right now, I have 5 hoodies, 6 shirts, 5 shorts. Let's take away pants here. I'm not going to wear shorts and pants. That's a little weird. I have 5 hoodies, 6 shirts, 5 shorts, and 3 socks. How many different outfits would I have if I wore one of each? Now, don't get picky. Don't get picky here and say if I'm wearing a hoodie, my shirt's uncovered, whatever. Okay? Let's make this instead of hoodies because they'll cover up vests. Okay? So how many different outfits could I wear before I had to repeat a full outfit? So this is going to be my vest. I have 5. I have shirts. I have 6. I have shorts. I have 5. And for socks, I have 3. And I'm just going to multiply those together. Can I do it? Mentally, 5 times, that's 30. 30 times 5, 150. And then 150 times 3 is 450. Let's see if I'm right. 5 times 6 times 5 times 3, 450. So I have 450 total choices. Okay. Same one. Well, here's a different one. Okay. Same type of idea, this one. We're going to change it up a little bit. But same type of product idea here. So there are 3 sections of a combination lock. Each dial can be set to one of these numbers, 1 through 8. Okay. What's the total number of different 3-digit numbers that can be used? And let's say assuming no repeats. No repeats allowed. Okay. And the way I set up a lot of these questions, I put 3 different blanks. And I work from there. So how many options would I have for the first number? How many options would I have for the next number? And how many options would I have for the third number? No repeats available. I'll give you time to work it out. Well, for my first number, and I use dots for multiplication, I'd have all my options available, so I have 8 options there available. Okay, now let's say I used an 8. How many numbers do I have left? I have 7 options left. And let's say I used 1. I would have 6 numbers left. So it'd be 8 times 7 times 6 times 7 times 6. Oops. 8 times 7 times 6, which will give me 336 options total for that 3-number combination lock. let's do this one. What happens if I could reuse numbers? So if I could reuse numbers and use numbers over and over again. Same thing here. I have 1, 2, 3, 4, 5, 6, 7, 8. How many different options would I have? So if we're going to reuse numbers, I would have 8 here the first time. And even if I picked 8, I still have 8 options again. It would be 8 again and 8 again because I have that many options for each one. Unlike the other one where once I used it, I couldn't use it again. So that's going to be 8. 8 times 8 times 8 is 8 to the power 3. So I have 512 options now. Okay. So here we go. So Chris wants to make a 5-digit number using the following numbers: 1, 2, 3, 5, 8. How many different numbers less than 7,000 can he make? So I'm going to put 5 digits here, so I'm going to put 5 blanks. Less than 7,000, so figure out first how many numbers can go there. Okay, then fill out the rest. Now I give these pauses. You can pause it here. I stop talking as a pause. So for the first number here, I need a number less than 7,000. So these numbers here can be used to make a number less than 7,000. So I have 4 options. Now let's say I use 1. When I get to the next number, it doesn't matter what number I have. So I have these 4 options to put in here. So it's 4 again. Let's say I use 8 this time. I'd have 3 numbers left. Let's use that one. Then I have 2 numbers left, and then 1 number left. So that's 4 times 4 times 3 times 2. Okay. So 4 times 4 times 2 is 96 total options. Okay. A little bit the same here, but a pizza parlor sells 10 different pizza toppings. So we have 10 options to go here. Grace is going to order 3 different pizza toppings, only 3. How many different pizzas could she make using 3? So she has 10 options, only 3 different toppings. So what I'm going to do is I'm going to put 3, and let's add in no repeats. You can't, no triple cheese going on here. Okay? We can do one later with repeats. We'll do repeats down here. Because if you love pineapple, maybe you just want 3 pineapple on it. So, what's our numbers that go in here? How many options do we have for the first one? We look up the board. We have 10 options. Now let's say we use pepperoni. We can't choose it anymore. So we have 9 options left. Then we used bacon. We used mushrooms, which are the grossest thing ever for me. So mushrooms, yuck. But we put on the pizza anyways. I'd have 8 options left. So 10 times 9 times 8. What's that, 720? If I'm not mistaken. 10 times 9 times 8. Oops. $720. Now, if we did have repeats, what would it look like? If we could put multiple of each. And I could change this where we even have, let's do repeats first. If you did have repeats, and you need to keep pausing the video because I'm going to keep going. So every time I ask you a question, you pause it and see if you can figure it out. If I had repeats, I'd have 10 options the first time, 10 options the second time, 10 options the second time. Because I could go pepperoni, 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 right? And I would have 1,000 different options for my pizza. Now I could make it even more a little bit difficult, and let's say I could have 2 items doubled. So if I love cheese, I could go double cheese. How many options would I have there if I could have 2 items doubled? So I could go, if I wanted cheese, then cheese. Now I've doubled an item, so it's no longer available. So I'm going to have 9 at the end of it. Because if I go cheese, cheese, that's off my list now. I can't take cheese anymore. So I'd have to take one of the other 9 items. So that's why it's 10 times 10 times 9, which would be 900 different pizzas I can make. Okay. So Jackson wants to make a 4-digit number using all the cards below. But it has to be greater than 6,000 now. So 4 digits are going to be like this. We'll give you a second to work that one out. Now I'm going to put my number here. So I have 3 things that are bigger than 6. So I have 3 options. Now let's say I use 9. How many left over for my next one? Well, there are 3. Let's say I use this one. There's 2 and then there's 1. So that's 9 times 2, which would be, I have 18 options for numbers. Oh, let's do this one. So let's say you're on a ship and you have 4 flags, and they use the flags to signal other ships. Okay? I could, on my mast, I could put up 4 flags. I could put up 3 flags. I could put up 2 flags. Or I could put up 1 flag. What's the total number of messages I could send? Like, for example, if I went like green, then blue, I don't know what it could send. It could send a message that I'm in trouble, pirates have me. But if I add a red to it, I had blue, green, red in that order, right? Because orders would be different. That may say I'm on my way to the Montreal port. And that would be different from a red, then a blue, then a green. That would give a totally different message. These are different, right? Because order matters. So how many different messages could I send? And I give you a little hint here. You can pause it here as you work it out. So, which way should I go? I'll move my way up first. Let's move my way down. We've been doing big ones first. So if I had all 4 flags available, I'm going to fly 4 flags. I got the first flag at the very top of my pole. I have 4 options. I could go purple, red, blue, or green. So let's say I took purple. That would mean I have 3 options left for my second one. And if I took blue, I'm just using it as an example, I would have 2 options left for my next one. And if I took green, I would have 1 option left for my last one. So that'd be 4 times 3 times 2 times 1, which is 24. Now, if I were going to fly 3 flags, my first option, I have all 4 in my box. I could pick any 4 of them. Let's say this time I take the red one. After that, I have 3 options left to pick from. So I have 3 there. Let's use the green. And then lastly, I would have 2 options between these 2, the blue and the purple left. And then we could just keep going like that. Erase this. I have 2 options, 2 flags. I have 4 at the first, 3 at the next, which would be 12. And if I'm just flying 1 flag, I just have 1 available. So that'd be 4. And then I would add all these up. 48, 60. I'd have 64 messages I could send using these 4 flags. Okay, let's do this one. Let's use I have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want a number. Let's do a 6-digit number with odd starting number and an even last number. Okay. I'll let you figure that out. So I'm going to underline all my odd numbers. So in total, we have 5 odd numbers. So I'm going to make sure we have 5 options for the first number. Now for even numbers, we also have 5. We have 5 numbers here. Now what I like to do is I like to pick numbers. Let's say I start the number with 9 and I end it with 0. That would mean for this next number here, we have 8 options left. If I pick 1, I would have 7 options left, then 6, then 5. Boom, boom, which would leave me 1, 2, 3, 4, 5 at the end. And then my total numbers I could build would just be those numbers multiplied by each other. 5 times 8 times 7 times 6 times 5 times 5. I could have 42,000 numbers with those rules. Okay? So that's an overview on product law. So product law, the big thing here is all my choices are independent. Okay? Like, hypothetically, these quite aren't independent because like once I choose a number, it affects another one. But it's the same type of thing where we multiply each other. Like this one here, we had the combination where we couldn't use the number. 8, we had 8, then 7 times 6 as we go down. Okay? These ones are independent there, and we're all good. Okay? So, do your homework up, and then I'll be ready with your next lesson.